so let's tie all of our newly gotten knowledge together. Let's learn how to spec out a computer. So let's say my computer, you will typically have someone say like, oh, I have an Intel i3-10100F. I have 16 GB DDR4, even though saying DDR4 with this is redundant, but it's DDR. I want DDR4. 16 GB DDR4. Let's say we got a 1080 Titan Ti, 8GB graphics card, and then we're also going to say, let's say we got at 1 TB M.2 and a 10 HDD, and then what else is interesting to spec out? Let's say, oh yeah, they're going to say Windows 10. Okay, so this is typically, like if you ask a geek or if you ask somebody who builds PCs, what are your specs? This is what they're probably going to answer with. They're going to answer with their processor, their RAM, their graphics card, their primary boot, or their first thing where the actual like OS lives, extra drives they got them, and then their operating system, okay? So they don't tell you what these are, you just have to figure it out. So again, Intel, we know that an Intel i3 is a naming convention for some kind of processor. So we know this is a processor. And we can go Google the Intel i3 10100F. 10100F, and we can compare it to other stuff like ours. Like maybe it doesn't say Intel i3. Maybe they say something else. Maybe they say I got a Ryzen 5. I got a Ryzen 5, say 3600. Okay, this is actually looking eerily similar to my build. Actually, my home PC. So actually, this is my home PC. My processor is a Ryzen 5 3600, which means it's the middle tier AMD processor. 3600 is a type. They have like different sub tiers, if you will. So it's like 3600 and 3600X or whatever. Mine's a 3600, this is a sub tier of the Ryzen 5. Okay, and then it says 16 gigabytes of DDR4. This is your RAM. We're talking about RAM here. Okay, so you got 16 gigabytes of RAM. Now, DDR4 is actually redundant because the Ryzen 5 series, well, that's only going to take DDR4. So if someone said DDR3, and if they said this is the build that I put together, and I put in 16 gigabytes of DDR3, and it won't light up, it won't actually do anything, well, you immediately know the problem there is that your RAM is not on the current generation for what that processor needs. That's why, Mr. Dude on the forum, that's why you have a black screen and it won't post or it won't do anything. You won't get to BIOS because you got no RAM, man. Or the RAM won't work with the processor. This right here, this 1080 Ti, that is a graphics card. And again, 10 is a generation that came out in like 2017, all right? So you have 10 is the generation, and then the following two numbers for a graphics card are usually the tier. So you know this came out in 2017. All right, and then it was a top tier. Right? 10 came out in 2017. 80 means it was like the best of the best of 2017. So 1080 Ti, that's a very good graphics card for 2017. And then they say, oh, I got a 1 terabyte M.2 SSD. Well, that's a hard drive, right? And they listed it first, so I'm assuming that's where their operating system lives. So that means their operating system lives on something really fast with a good bit of room, 1 whole terabyte on it. That's not bad. All right, so this is a hard drive. And then they're going to have, and then they mentioned this, another HDD. Right? And that HDD plus there, that second thing, is that's just like a big drive. This is where they put a bunch of files. HDD, this one's fast. All right, and then Windows 10 is your operating system. Now, Windows 10 does have different editions like Home, Pro, blah, 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 but really all the Windows editions are pretty much the same for computer users. Microsoft has like different tiers, like, oh, this one comes with Office. You know, no one uses Windows Office like Microsoft. Basically, you just make Windows. It's the only thing that it does. If it's Windows 10, all the same applications will run on it. Hey, you are fine. Let's talk about some stuff that really doesn't matter. There are two categories of stuff that doesn't matter. Stuff that's really complicated and stuff that's really not. All right? So here's some complicated stuff that really doesn't matter to us. Processor architecture. All right? Processor architecture is like x86 or ARM. There's some other ones out there. But this really doesn't matter. This for our purposes, this is actually talking about, okay, so what this is actually describing is this has to do with the instruction set that the processor actually has to execute instructions under this architecture. Now, if that sounds like Greek, that's fine. It's something to do with the processor and the operating system. They have to worry about that. You don't, right? As long as you might even see x86 in your file system somewhere and be like, I wonder what that is. Well, it's describing file system architecture or processor architecture. It has to do with software. That doesn't matter for us. So like things work the same no matter what kind of architecture they have. There are some gimme-gotchas, like it used to be that a particular kind of application called Docker would not run on Raspberry Pis because Raspberry Pis ran on an ARM architecture and couldn't do Docker. Used to be, now Docker actually runs on Raspberry Pi natively. Hey, great, they finally did something for ARM. Good job, Raspbian. That's an example of stuff that's like too complicated for the basic user. Like you're not gonna have to know that, right? Some stuff that doesn't matter is like, hey man, I have an Arctix ARCTIX Extreme cooler. Wow, you have a great cooler. All right, we didn't really talk about thermal throttling or thermal performance here because it doesn't really matter as long as your system is not like booting down and not like blue screening and shutting itself down, being like, yo, I'm getting too hot. Then your cooling is adequate and you're okay. So if people like boast about their liquid cooled or water cooled or super cooling thing, all right, cool, good for you. You probably overclock. Well, we don't overclock. We just want to build a system that works. And usually for your processor and your GPU, they come with stock cooling solutions that work just fine for what they are. So if someone like boasts about the cooling system, they're just looking to brag usually. What else doesn't matter? Your case, RGB lighting, none of that matters. There's a bunch of marketing terminology. Like remember in your graphics card, how there's like third-party board house manufacturers. Again, with the graphics card, we just care about the little chip. We don't care about who makes the general PCB that plugs into our Mobo. That has nothing to do with performance. Another thing that kind of is in a gray zone for does versus doesn't matter is your motherboard, right? This is kind of a gray zone because the motherboard doesn't have performance benefits, right? Like having a better motherboard isn't going to give you like more frames per second, but the motherboard does have to work, right? So it has to have a BIOS. It has to initialize all this hardware. It has to do its good job. So if you're having a problem with your computer turning on, with your computer posting, or with your computer randomly blue screening or something, you could have an issue with your Mobo. But again, your Mobo doesn't actually give you performance. It just ties stuff together. So all you have to have is a Mobo that works, that ties your hardware together. So that kind of matters, but not really, right? Now, what that means is you're never going to upgrade your MOBO by itself for a performance game. You're only ever going to upgrade your MOBO if you're like, you know what? My MOBO only has 2 RAM slots, and I've decided that I need 32 gigabytes of RAM, and I can't fit two 8 GB things. This by the way, like let's say this 16 gigabytes of DDR4. This could be 2 sticks or it could be 1 stick, right? So really, if they wanted to spec that out properly and say exactly what it is, they would say 16 GB, and then they would append out on the end of it, they would say 2x8 GB. Again, that's talking about, hey, I got 2 sticks in here of 8 GB each, which equals 16 gigabytes. But like, let's say we wanted to have a system that took 32 gigabytes of RAM, and we only had 8 gig sticks, which is common. We might just have 4 of these sticks, right? And that would be, it's a G, not a 6. G. Still looks bad, but whatever. That would describe RAM fairly well. 4 sticks of 8 gigabytes each, 32 gigabytes, DDR4, yeah, well, you're using a modern processor, of course you are. MOBO, it only matters because it ties stuff in. So if someone says like, hey, I have a gigabyte blah blah blah, or an Asus blah blah, or an AceRock blah blah, I mean, are you getting the desktop? If you're getting the desktop, then your motherboard doesn't matter anymore. It's serving its purpose. What else? What else doesn't matter? I know I picked on RGB, doesn't matter. Audio kind of does and kind of doesn't. Audio and USB are different things. Okay, so USB, there are USB 3.0 and USB 2.0 protocols. USB 3.0 is faster. It's a better protocol than USB 2.0. If you're doing like high quality video or something, you typically want to run a USB 3.0 for that. So like your USB ports, they're usually parts of your motherboard, that matters. But USB is universal serial bus. It's like the stuff you plug computer peripherals into, like your keyboards, your mice, your webcams, your USB microphones. That sort of kind of matters, but not really. As long as stuff gets connected to your computer and you see it show up, it's fine. You can even take devices that are designed for USB 3.0 and plug them into 2.0 ports, and really you can't tell the difference with performance. Like the average person just won't be able to tell. So this is kind of a system, and you should be able to read it again. You should be able to know what they're talking about. This is my processor, the Ryzen 5, blah, blah, blah. This is my RAM, DDR4, that's your RAM. This is describing a video card, video card. This is describing a hard drive, and so is this, and this is your operating system. So you get the idea of how all this kind of plugs in to make a computer. And you can kind of compare. You can compare. So if you know your specs and you know someone else has a card with like 12 gigabytes or 16 gigabytes, well, then they got a bigger, badder video card than you, and darn it, now you're gonna have to go upgrade to compare yourself to them better and more favorably. But that's kind of how computers work, and that's how building computers are. There's not much else to it. And I guess this concludes our series. If you have any other questions, feel free to keep it to yourself, because I don't read the comments at all. YouTube comments are some of the foulest stuff in the world, and hopefully a couple people found this enjoyable. It's been a good series, so I will see you guys next time I decide to record something and explain something. All right, bye.